talk about the spherical mirrors in this. In the previous class, we have spoken about the plane mirror and the images, and little bit two mirrors also. So there are two types of spherical mirror. One is a convex mirror, the other one is concave mirror. So these two mirrors are made by using a spherical glass ball. Okay, spherical. It is not a circle. Circle is different. Sphere is different. So these two mirrors are made from by cutting a sphere. So now, if you cut a sphere, that colored one is so that in that way also we can have a cut. So you will be getting a concave mirror. So that red color one goes inside, right? So that is concave mirror because inside that is the reflecting surface. Now this is in the other way also we can cut it. Now this is one more cut. So now this will be dark and reflecting surface the other side. So that those mirrors are known as a convex mirror because the reflecting surface will be like this. So now let us understand little more about the these two mirrors. Now see, the cross section will be like that. So now it is cut spherical, you are unable to view it, you take a square and cut it like this. So the inner edge is shaded with coated with the silver. So then reflecting surface will be this side. So we call that as a convex mirror. Now you take another one, you cut. So this side is coated with silver, then reflecting surface will be in there. So that is known as a concave mirror. I hope you have understood what is a convex mirror and what is a concave mirror. So convex mirror, the reflecting surface will come out. It comes out, right? So in opaque surface will be inside. In the concave mirror, reflecting surface will be in this side, and that is opaque surface. That means silver coated surface. So let us understand little more about the mirrors. A parallel rays of light is falling on convex mirror. Okay, parallel light, beam of light rays falling on the mirror. Yellow color rays are the yellow color lines are the rays of the light. So now they reflect in different directions. That means the reflection will be in the diverge, right? So that is why this convex mirror is also known as a diverging mirror. The other name for convex mirror is a diverging mirror because the parallel beam of light falls on them. All the reflector rays will diverge from the reflecting surface. So now let us, what happens when a parallel beam of light falls on the concave mirror. So now parallel beam is falling on the reflecting surface. So then what happened? All the reflector rays will converge at one place. So this place it is converge. Okay, at this place all the rays are passing through. That means they are converging to one point and going in the same direction. So that is why this concave mirror we call it as a converging mirror also, right? These questions will come in the short answer questions, like what is the other name for convex mirror, what is the other name for concave mirror, why convex mirror is called diverging mirror, why concave mirror is called as a converging mirror. These are the questions will come generally either in 1 mark questions or in 2 marks questions. Okay, explain why convex mirror is called as a diverging mirror. You have to explain it with a diagram. So it may be having 2 marks question. So now let us understand more about these mirrors, common terms, because you need to understand what terms are to be used in this. So let us it is a transparent medium, and every mirror, concave mirror or convex mirror, they have a center, and that center is known as C, and that C is known as a center of curvature. So center of curvature of the mirror is known as center of the sphere by which the mirror is made, or mirror is a part of. Okay, so first and foremost word is both mirrors will have C, center of curvature. Okay, so in 1 mark question it may be asked what is a center of curvature. So now let us understand pole. Now pole, you take separately one mirror. So the central part of the middle point part of the curvature of the mirror, like a P is there. So this P is the middle part of the reflecting surface. Okay, this reflecting surface, C already knows. So the this reflecting surface, the middle point, the center point is known as a pole. So that is why it is called as a geometric center of the spherical surface of the mirror is known as a pole of the mirror. Okay, so now let us understand one more, principal axis. So a principal axis, it is an imaginary line which passes through center of curvature and pole. So center of curvature and pole, a line will be, an imaginary line will be passing, and that line we call it as a principal axis. So now radius of curvature, I need not tell you radius of curvature. The distance between C and P is known as radius of curvature. Not only P, any point on the reflecting surface, the distance between the center of curvature and any point on the center of mirror is known as a radius of curvature. Okay, so the red color one is a radius of curvature. In simple you can write it, right? So these are the different terms we are using with respect to the spherical mirrors, right? Now principal focus, this is a very important term in these mirrors. So let us understand what is the principal focus of a concave mirror. Okay, so let us have, this is a concave mirror, right? For this it may come in the 2 marks question, right? So if it is asked like explain about the principal focus of a concave mirror, this entire procedure you have to write it. You have to draw a diagram also. So concave mirror is there here. So let us C, represent C. Okay, you have to be very careful when you are drawing a diagram. Okay, so C is the center of curvature. So then P is the pole. You mark P also, right? And draw principal axis also. So that means you have to draw a mirror, pole, you have to mark a pole, you have to mark center, and you have to draw principal axis. So then what happened? You have to draw a parallel lines, send a parallel beam of light which towards the mirror. So parallel means where to what it is parallel? Parallel to the principal axis. So principal axis को parallelly भेजना है. So this parallel light, rays of light, parallel to the principal axis. So once they fall on the concave mirror, that means the reflecting surface of the concave mirror, so they converge at a point. Okay, and that point, this red color point, that point is known as F, that is focus. That is also called principal focus. Okay, so this is the what is principal focus. Now let us understand the definition. The reflected rays meet at a point F on the principal axis, and that point is known as a principal focus of the concave mirror. So now convex mirror. Let us understand the principal focus of the convex mirror. Now the reflecting surface in the other side. So now for this also you have to mark a pole, you have to mark a center, right, center of curvature, you have to mark pole of the mirror, and you have to draw a principal axis also. And then you have to send the rays, parallel rays to the principal axis also. So the parallel rays to the principal axis fall on the convex mirror. So then what happened? They diverge. So they appear to the diverge. If you continue all these things, right? If these lines are continued on the other side, what happened? They all meet at one point, and that means they appear to diverge from a one point, and that point we call it as a principal focus of a convex mirror, right? So you can understand like this. For concave mirror, the focus will be in front of the reflecting surface. For convex mirror, the focus will be behind because the dotted lines is there, that is behind the convex mirror. So these are some logical questions. Where will be the focus of a concave mirror? So it is in front of the reflecting surface, and it lies on the principal axis. You have to remember this also. So focus always lies on the principal axis for both the mirrors. So one is in front of the reflecting surface, one is behind the mirror. In front of the mirror or behind the mirror. So these two words you can use it. So now let us understand the definition also. Definitions are very, very important, because sometimes define principal focus of a convex mirror. You should be able to understand the definitions. So by heart the definitions from the textbooks. So I hope this is okay for this length. One more point is there, focal length. For every mirror there will be a focal length. So the focal length is nothing but the distance between pole and focus. The distance between pole and the focus is known the focal length. Every mirror will be having a focal length. So how do you measure the focal length? You have to find out the focus first, and then you have to measure the distance between focus and the pole. So these things you have to do it in the lab also, right? All schools will be having labs, and it's very, very easy. Every student should be able to find the focus on the principal axis and the focal length of the mirror, right? So for convex mirror it will be the same. The distance between the pole and the focus is always focal length, right? So now the radius of curvature, focus exactly lies in the center point, the middle point of P and C, the radius of curvature. So radius of curvature के ऊपर exactly F is the midpoint of the radius of curvature. So therefore that is why R is equal to 2F, and F is equal to half radius. Okay, focal length is equal to half radius, or radius of curvature is equal to 2 into focal length, right? I hope you have understood all these points. Let us continue this lesson in my next class. Bye bye.